Alright guys, welcome back to another video. In this one we're going to be looking at doing a full section drawing. Now we're not going to be working with a past paper for CSEC or anything like that. And some of these specifications are going to be, the common specifications that they would, typically use for exams or maybe even real life. So we're going to be doing a full section drawing, and as you should know, a full section drawing is a cut that is from the roof, straight through the roof, all the way through the walls, through the floor, down to the foundation. So where this line runs is where this cut is going to happen, and um, then we are going to be looking in the direction of where these arrows are pointing. Okay, so usually for your exam you would be given a sketch, something like this, on paper, and it will give you all the measurements in terms of the widths for the rooms and the windows and doors. Well, they wouldn't give you for the windows and doors, but that would be on your specification sheet. But they would give you it for the size of the rooms, etc. So basically you have the freedom to turn your paper around to do your drawing. I'm going to turn, actually let me just make a copy of this first, and then I'm going to turn it around. All right, so I'll just rotate um, 90 degrees, like so let me just get rid of this. All right, so basically what we have is we're cutting through the roof. They'll be cutting through these walls, this wall, that wall, this wall right here. We are cutting through a door because this door will be closed. I really wanted this to be cutting through the window so I could show you that also. So let me let me move the cutting plane line so we could cut through the window like so. All right. So I could, well, there's multiple ways you could do this, but I'm going to show you from the perspective of your exams, because in the exams, remember, you're going to have a sheet with a sketch, a line sketch. You're not going to see the thickness of the walls, but when you do the drawing, you have to show the thickness of the walls. So I'm going to do it using this sketch, but I could have done it using um, the completed floor plan. But in your exam, you're not going to have a completed floor plan to work from. So, but in real life, what I typically do, because the floor plans would be one of my first drawings, and then everything else is going to be built after that. What I would do, I would pull projection lines down. So from the projection lines I would get my wall thickness, the location for the windows and the doors and everything like that, and then I would just fill them in where they lie. All right, I'll probably do another video on that for doing a proper um, section drawing, but for the sake of this video and preparation for CSEC exams, I'm going to do it with just the line sketch. Okay, so let's start. Let's go to the wall layer, and let's start with some lines. Now these lines are not going to be um, any particular length as yet. We can cut them off after. This is going to be a wall, because remember, we're cutting through um, the roof down to the walls, down to the floor, into the foundation. All right. So I'm going to be drawing starting from this side first, coming across from right to left. So when I cut through this wall is going to be my external wall, exterior wall, and you have to look at your specifications. The specifications might say that both your interior and exterior walls are 150 millimeters or 6 inches. Um, it might say your interior walls are 100 or 4-inch blocks, 4 inches. You need to look at your specifications. For this drawing, we're going to assume that all of the walls are 150 millimeters, 6-inch blocks, internal and external. All right, so this is the first wall. And I'm going to offset 150 millimeters. All right, that way to the left. Okay, so we have the fourth wall. Remember, we are standing here. We cut the building, and we're standing where the line is, and we're looking in the direction of where the arrow is pointing. So what do we see? We see this wall, and we actually cut through the wall. Okay. Now let's get another measurement. We need to know what's the distance between this wall and this wall. It's the same down this side. So if we look at the measurements here, we could just CSEC would probably give you the measurements. Um, for example, like this, they would probably show you the measurements like this. So you would be able to say the distance between the inside of this wall to the inside of this wall is 3,300 millimeters. So basically from the inside of the wall to the inside of the other wall is 3,300 millimeters. So let's offset that, 3,300 millimeters, this one to the inside. And then we're going to be meeting this wall right here, okay? Um, which is um, going to be another 150 millimeters. Um, let's ignore this part for now. Okay, so let's say we meet this. We're looking at this wall. Where the line is, we're not actually cutting through the wall, but we're going to be seeing right here. Okay, so let me just, after we have that distance for the size of the room, we're going to offset 150 millimeters to the left again. So now we have this wall and this wall. All right. So what do we need now? We need the distance between here and here. Now CSEC would also provide you with all these measurements, these information. I am just, pulling. I would have to just pull the measurements up myself as we go along, but CSEC would provide you with them. So let me just pull this across. So the distance between the inside, the left side of this wall, and the right side of this wall, all right, from inside to inside measurements, that's what we're looking at, is going to be 1200. All right, so let's offset again 1200 from the inside of this wall to the left to that wall right there. This wall have to offset 150 millimeters like so. So that's this wall, your bathroom wall. All right, and now we want to know what is the distance from the inside of this wall to the inside of that wall. It's 2400 millimeters. So offset that, and then the thickness of the wall again offset 150 millimeters like so. So here we have all the walls for the house, for the building. So what we want to do now is draw a line coming across here to represent the finished floor inside of the house. All right, I'm just gonna trim off the excess like so. Next, what we're going to do is draw a line to represent where the top of the wall is going to be. Now CSEC might give you this information. It might tell you, oh, the top of the wall um is, you know 9 feet 27 2700 millimeters, or 10 feet 3000 millimeters. um and that top of the wall would include your um well, they might specify and say the distance from the top of the floor, which is this line, to the top of the ring beam is 9 feet 2700 millimeters. And then they might tell you what the um the specifications are for the wall plate that will go on top of the ring beam. Now that is the reason why I wanted to do these drawings first, um, so that when we are doing the full section, you know exactly what goes into the foundation and so on. And the eave detail, when we did this one, well, you don't have the video for this one as yet. Hopefully soon. You know that this is your wall, your external wall, and then at the top of that wall, well, if we go up to here, this is the top of the wall. But 8 inches down, we have from the top of the wall, we have the ring beam, okay, which is concrete with steel inside of it and a bolt to bolt down the wall plate and everything. So what we have on top of the ring beam is the wall plate, which has the bolt running through it and everything like that. So they would give you the specifications. All right. So for the sake of this drawing, let's say that the wall plate, well, not the wall plate, the top of the ring beam is 10 feet, which is 3,000 millimeters. So we're gonna offset 3,000 millimeters from this line going up like that. Okay. And then we could just trim away these lines. We don't need these lines anymore at the top. So here we have, down here is where we're going to be putting the um, foundation. Let's get rid of these also. And here we have the top of our floor and then the top of the wall. All right. If there's a ceiling, it might tell you the ceiling is, let's say, 8 feet from the top of the floor. So you might have to draw offset a line 8 feet, 2,400 millimeters from the floor. That's the ceiling, and above here is where the top of your wall plate is and all that. But let's assume there's no ceiling. All right. Right. So these are the walls that we cut through. This wall, we cut through this wall, we cut through this wall, and I believe a door is going to be right here. Actually, we didn't cut through the door again because we moved the line down. So we're going to be cutting through a wall, right? That's the bathroom wall, and this is the bathroom, the external wall for the bathroom, right here. So we're going to be cutting through that, and a window is going to be there, all right, in this wall. It's a bathroom wall, so it's going to be higher up, and so on. Anyways, um, as I said, the reason why we did the foundation detail drawings and all the eave detail drawings first is so that this will make a lot more sense. Because when we do when we're doing the other parts of this section drawing, like the roof and the foundation, it's basically going to be these drawings that we already did before. All right, so let me just show you what I mean. We'll draw it still, but let me just show you what I mean. If I turn off these dimensions, all right, if I just copy this, I'll let me pick it up from around here. I pick it up from the floor slab, the top of the floor. Okay, so essentially what you're going to have is this. You're going to be placing your foundation. You're going to be drawing in your foundation underneath of the drawing. However, and this is important, when you do a section drawing, a full section drawing, you're not going to have as much details as the detail drawings. That's why they're called detail drawings, because they're going to show you, yes, this is a footing, yes, this is a foundation wall, but they will not be showing you the steel inside of the the footing, the steel inside of the foundation wall or anything like that. It's just going to be showing you the main members, but not necessarily the details inside of them. All right. Even these details where you distinguish between the finished floor, the concrete slab, the damp proof core, the sand binding, the hard core, and the earth, all of these details would not necessarily be shown. What you would be showing is maybe just 2 lines to represent the concrete slab. But we know that when we do a detail of the foundation, you will have to show all the parts of that concrete slab. All right. So what we would basically draw back these detailed drawings without some of the details, such as the steel, as I said. All of this would be consolidated into one um, member. So we will not show the separation between, the finished floor, concrete slab, sand blinding. We would probably just have two lines to represent the concrete slab, and then underneath it will have the hard core and maybe some art, but not the details in between. Okay, so let's leave it like so and continue with the drawing. All right, so let's head back over to the drawing over here and let's continue. Let's start with the foundation. Um, First thing we're gonna do now, CSEC might give you the details. They might tell you, oh, that the concrete slab is 4 inches. Um, for the full section, do a 6-inch concrete slab. Let's do a 6-inch concrete slab, and that is going to include, the finished floor and the sand blinding layer and the um, concrete slab itself. So the concrete slab is 4 inches. 4 inches, the top layer, which is the floor finish, which is about an inch or less, and then the sand blending layer, which is another inch or so. Right? So that's 6 inches. So let's offset that. 6 inches, 150 millimeters. Right, come down. And then underneath of that, we can do um, the footing, the foundation wall and footing. So what I like to do is to draw the footing by itself, similar to how we did this drawing here. But instead of doing the um, external wall, and the footing, I'm just going to do the footing and the foundation wall together. So I'm going to draw foundation wall. I'm going to put this down, let's say 3 feet, 2 feet, sorry, so 600 millimeters, and then I'm going to offset that 200 millimeters because that is the specifications they would give you. 8-inch block, 200 millimeters. The reason why I came down 2 feet is because that is the minimum distance that the footing should be buried. So CSEC might give you this information, but if they don't, you should know these details. It would also give you the specifications for the footing. Now the footing, they might tell you the footing is 900 millimeters wide by 300 millimeters deep, like so. I've seen this. I've also seen specifications of 200 millimeters deep by 600 millimeters wide, like so. Whatever they give you, if they tell you the dimensions for the footing is 300 by 900, just know that the footing is wider. The strip footing is going to be wider than the depth. So if the 900 obviously belongs to the width, and the 300 belongs to the depth. If it's 200 by 600, that is how it is. So depending on which measurement they give you, this is how you would put it in. All right. So I'm just gonna draw a line here so that I can know where the center is, and then I'm going to use the one 200 by 600 and move this, grabbing the center, the midpoint, attaching it right there. Okay, so I don't need this one anymore, but I could have used that to make it also. The reason why I use this is because typically the width of the from the width of the footing is 3 times the width of the foundation wall block. If this is 800, then this must be 3 times 800. So now I'm just going to close this off at the top, and then I'm going to take a copy of this and grab it by the end and put it to the end of the wall like so. Alright, I'll just need to draw a line to come down here to connect the concrete slab, and then I want to do the same thing for the other side. Now remember, underneath each load bearing wall there is supposed to be a footing. Okay, so there's going to be a footing underneath of this wall, there's going to be a footing underneath this wall, there'll be a footing underneath this wall. It actually would be all the way across here, although this wall stops here and continues there. There really is going to be one continuous, maybe this is an archway opening, there's going to be one continuous footing going straight across. So essentially you're cutting through a concrete footing right here also. So there's one here, one here, one here, and one here. So the difference with these two, however, we have to put them in the center. All right, so we just need to find the center of this. So we could do it one of two ways. We could use the annotate center line and click on the two lines, and it will create a center line right in the middle, and then I could just extend this down. That's where my center would be. The other thing to do it would be to extend these two lines and then draw an X from the corners, all right, diagonal lines. Where these two diagonal lines cross, that is the center of these two lines here. All right, so I'm just gonna make a copy of this, grab it in the center, and place it right there and there. All right, and now I could just get rid of these lines. Oh, sorry, get rid of these lines. My bad. Let's do that again. These lines, and then trim away these ones, and then let's trim these out. Oh, I can't trim this because this is the center line that it created. All right, so there we have the footing and the foundation wall, external wall, concrete slab. Now, this does not have to have all the details, as I said, of this, right? So um, this is how we're gonna leave it. We'll just put in the hatch like concrete and the mitre line, the 45-degree mitre line here and up here, concrete for this one, and then we'll fill in underneath also. So underneath of so in these two lines we have the finish floor, right? Then we have the concrete slab, and then we have the sand blinding layer and the damp proof core, and then underneath of that we have 6 inches of hard core. So offset come down, that's 6 inches of hard core, and then underneath of that now we'll have earth. I'm just going to offset, let's say 200 millimeters, 50 millimeters of that is going to be earth. Now it doesn't have to be 250. I'm just putting a line here to represent the earth. All right, the earth layers. Let me just trim out these lines. All right. And then I could probably just fill these in right away with the hatch. So let me just go to my hatch layer. Then I'll go to the AR conch right here, and then I'll fill this. Let's see. I might have to change this number. Let's try 1. That doesn't work. Let's try 10. That doesn't work. Let's try 100. Still doesn't look like anything changing. Let's try 500. Nothing. Try 1,000. Nothing. Maybe let's try something less than 1. So maybe zero point 0.5. Nothing. I think something is off with my settings here. All right. Because if I look back at my settings I have for this one, I'm pretty sure. Okay, it's 20. So I'm pretty sure if I use 20, it would not show up properly, even though. So let's try 20. See, same thing, doesn't work. All right, so let's try it again. 20 and like so. Ah, now it works. So all of these are concrete. Um, and then here is concrete also. And then let's do another hatch. But for the walls, actually let's do the hardcore, which will use gravel. The gravel. Uh, mm, where I think I missed it somewhere, or maybe it's below. Ah, here it is. All right, so we'll put in the gravel. This again, I may need to change. All right, so it's too small. Let's change it to maybe 100. All right, and I put it in the wrong place. All right, so we'll use 100, but I put it in the wrong place. Or actually, I'll use something maybe 200. All right, so um, gravel. Let's use 200, and we'll put it under here, there, there, and here. And then finally, we'll use the earth and fill it up. Sorry. No, I'll have to close hatch and do it again and use earth this time for here, here, here. Let's change this to maybe 300, like so. All right, and then now we'll use the hatch again to do um, the walls like so. Let's change this maybe to 500. Nah, let's use 1,000 or 800. Let's use 1,000. See, all right, 1,000 is fine. Oh, undo, do that. All right. So um, it's a hip roof, so the roof will come right down to the wall. So this is the back of the walls that we're seeing. So that's why this line is here. Um, so um, actually, if we're standing here in the bathroom, then this wall might come all the way up. It might come all the way up to the roof. So what that means, if we're standing here, we're gonna see this wall all from the floor all the way up to the roof, from the floor all the way up to the roof. That means we're not going to be seeing um, the rafters that would be behind here. We're not going to be seeing the rafters. All right. So we'll have to probably get rid of this line. But before we do, let's put in the roof. So we're almost done basically. Well, sort of. We might have to delete these hatches to put in the windows and everything, but I just wanted to put them in now so you could see. Um, so I'm gonna do this. Right, cool. And now, remember, we are not actually cutting through a wall here, right? So technically, you would not be seeing when if we were cutting through this wall, then we would have to put a hatch here, but we didn't actually cut through a wall. It's an open space, and we'll be just seeing the face of this wall with a door in it. All right, so what I have to do is get rid of this hatch. So I'll have to separate hatch so I could delete this one without affecting the others. And then secondly, I'll have to remove this line, because if we are standing here, then imagine that this wall comes all the way across and that door is in front of here. So what we're going to be seeing is a wall with a door and continuing on the other side of the wall. All right, so I can delete this. So what we'll be seeing is the face of a wall. All right, up this side we'll be seeing the kitchen window, the stove, the fridge side of the fridge, and so on. All right, so before we do fill in the details in here, let's do the roof. So let's go back to the wall. Um, so the specifications, they would give you the specifications and say maybe the rafter is 2 by 6 for the rafters. Yeah, so what we'll have to do, um, I think they would also probably give you the height, like of the ridge. If they don't give you the height of the ridge, they might give you the pitch. But usually they give you the height, the different heights. So they might say the height from the floor to the bottom of the window, or from the height from the floor to the top of the ridge, and so on. And if you could just offset those distances, um, so let's say they give you that, you just offset it and do it. So let's say they say that the distance from the top of the floor to the top of the ridge is 4500. You would offset 4500 from there, like so. That's where the ridge would be, right? This ridge, which is in the center. And then you would have to offset downwards the dimensions for the ridge, which is 2 by 6. So 6 feet, come down, 6 inches, sorry. And then where is the middle? Right, so I'm going to just draw a line down so I could offset an inch on each side, and that's my ridge, right? And from this ridge we could now draw our line from the ridge to the corner, like so, like so. And then we know the overhang. They might give you the overhang, say it's 2 feet 600 millimeters, or 1 foot 300 millimeters. They would tell you what it is. Let's say it's 2 feet, so I'm going to offset this line 600 millimeters, like so, on each side. And then I would extend this line out to meet it. So now I could erase this. All right, and then I would offset 150 millimeters, which is the thickness of the rafter, upwards, like so. And then I could bring this across like this. All right, and then what I would probably do is just bring this up. The other thing you could do is start do the top line and then come down. But when I do this, I like to use the bottom line because I could rest it right on the roof one time. Okay, so I'm just gonna clean this up. All right, so that's your ridge in between there. I'm gonna just put a X because it's the end of end of a member that was cut. So these two lines here represent this hip and this hip, right? But looking at it, if I'm standing here and I'm looking at it from here and here and here, looking at this whole hip, it's going to seem like it's just um, in the drawing, it's going to seem like it's just going across. But really, it's actually getting further away from you the more you down you go. All right. So that's one way we could do it. Then we just have to do the notice I'm going up, right? Because the way the bottom line was, that's where the fascia board was going to be, not the top line. We offset the top line, so it's sticking far a little bit. So we don't need that. So let's do the same thing on the other side, like that. Trim it off, trim this off, and then I'm gonna offset 25. So that's the fascia board, like so. Now the fascia board supposed to be, they might give you the specification. So let's say it's 8 inches. Right now it's 160 millimeters. So we could extend it by clicking here, lengthen, add on the right. Initially it's 160, so we could add on the remainder, add on 40. So we could type 40, hit enter, and if I check it again, you would see it's 200. Right, so we probably should have done that first before offsetting it. All right, so let's go across this way, 25. um, and then I could just extend this down and then close this off at the top. Again, I'm going to do that because it's the end of a member that was cut. I'll do the same thing on the other side. All right, actually, I'll just copy this. All right, so copy this and grab it from this side and put it over here. Actually, I don't need this. I'll delete that and I'll just move this in place like so. All right. Because remember, you cut through the fascia board that will be running here, here also. All right. So, so there's a couple of things. If these walls don't go all the way up to the roof, if they just stop, let's say they stop right here, then we can show the rafters. All right. So let's say I do run a line down here. So I'll trim it off, and then I could offset an inch on both sides. One, two, and then I could remove this line. So that's one rafter. All right, so let me just, I don't know if I have a rafter layer, but it's good to have layers for everything. So yes, I have a rafter layer. So let me just switch this to my rafter layer. And then now what I can do, I can draw a line coming across here so that I could get the center, right? So I can highlight it and then do a copy and select the center. Now remember, your rafters are supposed to be placed um, 600 millimeters from each other, measuring from the center, from center to center. All right, so if you measure from the center of this rafter to the center of the next rafter, it should be 600 millimeters. So I'm just going to copy and then type 600, 1200, 1800, 2400, 3000. Oh Lord. Undo that last one. 3000, 3600. I'm not sure if I already passed it. Okay, I haven't. Good. So you don't have to use multi lines or anything to do this. You could just do what I just did there to get the two lines. All right. And then since the left side is a mirror of the right, I could just use the mirror. Actually, I won't need this one. I would just mirror these, MI, mirror, and I would draw a line right down the middle. Here is my mirror line. It's because I don't want to mirror the middle, because it's just going to put a line right back in the middle. So don't erase the source, and there you would have your rafters, right? But remember we said the walls, like this wall for example, might come all the way up to the roof, which means if it's up to the roof and I'm standing here, this wall would be blocking my view of the rafters behind. All right, so that would happen all the way across here, all the way across to this wall. Okay, so what I will have to do, so all the way across to this line means we would not be able to see the rafters, all these rafters. Okay, which means we would have to carry the wall all the way up, um, including this wall here. This would have to go all the way up, all right, to the roof. So we'll have to get rid of all these lines if we do it this way, depending on what you ask for, right? And this wall would have to go up to the roof like so. All right, we can get rid of this, and as I said, we'll have to get rid of the hatch lines because we still have to draw the window back into this wall here and so on. All right, so we'll redo the hatch. There's supposed to be a door in here, so the door is going to be, they would give you the specifications for the door. Let's say the door height is 2000 millimeters and the width is 750 or 900, whatever it is. I don't know what this is. Let me measure this. I'm going to just use the width. So 900, and the height of the door would be say 2000 millimeters, right, which is almost 7 feet. So I'm going to draw a frame for that door. Let's say, go back to my wall layer. So 2900 across, right? 2000 come back down, and then I'll just close it off at the bottom. I don't actually have to do this part at the bottom, but I will I will leave it there so that I could pick the door up from that midpoint. All right, so that door, if I'm looking at this, it's not exactly in the center. It's roughly, it's closer to this. It's closer to this wall. So I'm going to take the door up and just place it in here. CSEC usually tells you if they don't give you the measurement for something, use your discretion. So this is where the door would be. All right. Now I could just simply a door handle in there like that, and your door is complete. Or if I want to get fancy, I could import um, one of these doors from the design center. um, we could use the plain door or we could use the fancy door. If we use the plain door, it will be essentially the same thing as here, so I'm not going to actually import the plain door. We could bring in the fancy door, and then we could just rescale it so that it fits inside of this frame that we drew. All right, so if we wanted to rescale this, you all should know this, we need to measure the height of the door that we have here. All right, this one is 2131. So what we're going to do is select it, scale, select a base point. It asks, we're going to hit a reference, and then we want to put in the actual length, which is 2130. What was it? 2134. Right, 2134. Scale, select a base point, reference, and then the reference length 2134, and then the new length, which is going to be 2000. That's the height. So now this should be 2000, but always check your measurements because sometimes AutoCAD act funny and it will be 2001. So that's that. We're gonna take this and place it in the space like so. All right. Not sure what this is going on here. The other problem is what we have is that we have the right height, but the width will not be the right width. So what I like to do, I like to scale the door so that it fits the proper width first, and then I could explode it and stretch the door to the proper height. All right. So what I would do is measure the width of the door, 8, 857. So I'm going to use the scale tool, select a base point, reference, and then 857. That's my reference length, and then the length I want, the width I want it to be, it's 900. So now it should be the correct right width. So it would fit in here as the width, but the height has also changed, and now it's a little taller. It's 2100. So what I would do is select it, explode door, and then I would use the stretch tool, select the bottom part of the door, enter, and then I'm going to make it shorter by about 100 millimeters. So I'll just type on 100 millimeters, and now the door should have reduced the height by 100 and be 2000 by 900. Put that over to your openings layer, which is doors and windows for me. And I'll just take it up right here and put it in the space. So that works too. All right. So this wall will go all the way up to the roof, which means I would not see this line. Okay. Um, this wall also goes all the way up to the roof, so I would not see um, this line here. But what I would see is this line going all the way up to the roof, like so. And I should have just used the extend tool to lengthen that line. Right, so that's what I would see. This wall going all the way up to the roof, this wall going all the way up to the roof, this wall here and here. Alright, so if we are here, then we are in front of the sink, the basin, so we won't see the basin. This door is closed and we won't see it because we're not cutting through it, we're just cutting through the wall. But we'll see the toilet, and we'll actually be cutting through this window, and we'll actually see also the tub, well, the part of the tub that we're cutting through. All right, so let's say 2 feet off the ground, offset 600, like so. That is where the tub would be. And let's see, how wide is it? 914. So I'll offset 914 millimeters, like so. Right, and then I could delete this line. So this is where the tub would be, and then remember we're cutting through the tub. So this doesn't have to be an exact thing, but I'm just going to draw this little rectangle there and fill it. Let me do multiple radius. Let's see, the radius is 20. We'll try some things out and see how it works. Alright, so 20, I don't think 20 is enough. Undo those. Let's try change the radius to about 50 and do that. So remember, we are cutting through the tub. Now the tub doesn't go all the way down to the ground. The tub is like here, and then the inside of the tub is where the water goes. But we cut through it, so this is what we would see. And if you want, you could actually put some hatch lines like here in the tub. And so let's fill this up. I'll have to switch the layer, maybe. So I'll switch the layer for this back to the hatch layer. All right. And then if we're looking, we'll also probably see the toilet off in the back there. So if we go to the design center, we'll have a side view of a toilet. I want to switch this to my fixtures layer if I have one, and I'll put the toilet in the back there where it should be, like so. All right. So it seems as if the, how tall is this? It's 2 feet high. I think a toilet might be a little higher than this. It depends, but let's make this toilet like 3 feet high. So let's scale it. What's the current measurement? 610. So let's use the scale tool. Select this, select a base point, reference, and the reference measurement is 610, and then the new measurement will be 900. So it's a bit taller. Alright, so we could put the toilet there, and then I'm going to explode the toilet so that I could trim the parts of the toilet that would be hidden behind the shower, the tub, like so. Alright, so you would not be able to see all of this if the tub is in front. This part of the tub is in front of the toilet, we can't see. Alright, like so. So you'll have the toilet behind there, but we just can't see all of it. It's sticking out. So we'll do fixtures again. Like so. I'm not sure what this is right here. Just region all gone. Alright, so there's a toilet. The door is in this wall, but we're not cutting through the door. Let's put in the hatch for this wall here, and the hatchback for this wall right there. Okay, so this is, we're basically done. Oh, sorry, we need to put the hatchback in. So I just gotta delete this. Take the hatch out for this because a window goes in here. So let's say my window, I want to draw a line at the bottom so that I can offset it upwards. So let's say the bottom of my kitchen, my bathroom window is, let's say, 5 or 6 feet off the ground. So I'm gonna offset this 5 feet, let's say 1800, so that's 6 feet, because 300 millimeters is 1 foot, times 6, 300 times 6, 3 times 6, 18, so 1800. So that's where the top of the bottom of the windowsill for the bathroom would be. And let's say this window is 2 feet high, so let's say 600. That's where it would be. So I'm just gonna draw a line in the middle, and then offset an inch on each side, like so and so. And then I could get rid of this one in the middle. Alright, so this is going to represent me cutting through the window. Alright, so let me just switch this over to my openings layer, and then I could put the hatchback around that. Alright, so let me just hatch here and here. So now the next thing we need is, what do you see if you're standing here? You're going to see the um, fridge, side of the fridge. I don't think there's a block for the side of a fridge, but it's just a rectangle, so we could draw that in. All right. Your fridge is about 5.5 to 6 feet high. All right, and I know that because my fridge is about my height. I can't see on top of it. It's about almost exact, and I'm 5'7" or 5'6". All right, 5'6", 5'7", 6'7". Um, so I could draw a line coming up, let's say 6 feet high, so 1800, come across. This really should be on my other layer. Let me just switch it one time. So I'll come up 1800, 6 feet across, and how I'm not sure how wide this fridge is. I could just take a measurement from this. Alright, so this is saying 711. It doesn't have to be that, but I'm just gonna use back these things. So 711, 711, and then come all the way back down. So that's my fridge, side of my fridge. Alright, I'll just put another line here, offset 25 millimeters. So it's like where the fridge, the door swings, the thickness of the door for the fridge. Switch this to my fixtures layer. Alright, I could even put a handle on it, but I'm not gonna do all of that. Alright, and then if you're standing here, you cannot see any of these cupboards. What you can see is this upper cabinet, this stove, and this 3 foot wide window. And a window is generally 3 feet off the ground. The bottom of the window sill, is 3 feet off the floor. But kitchen, because of the counter, which is also 3 feet off the floor, that means the window has to start a little higher. So the window would start 4 feet off the floor. So that means this window is going to be 3 feet wide by 3 feet high instead of 4 feet high as it would probably normally be. Alright, so I need to put a line offset 900 because that's the height of the counter. Alright, so right there, let me just trim away this and then I can delete this. I'll keep this one, delete these. Alright, that's my counter. I should have a stove in my design center, house design, home space planner. Where's the front? Oh, it would be in kitchen, sorry. Kitchen blocks. Front of the stove, where is it? This is the top. Do I have any stove front? This wash, oh, here it is. I should probably pull out a base cabinet too, but I'd like to draw these myself sometimes. So we'll see how it goes. The stove, this should be on your fixture. I'm just putting it on my fixture layer, so it's a little thinner. Then I'll put the stove right there. Okay, I could probably just trim away these, so I could delete that. Here, delete this. So that's my stove in the corner there, just like it is here. And then the counter runs across, then the sink is in the middle. How I know it's in the middle? Because the window is in the middle of the wall, and then there's a little counter disappears behind the fridge, the little cabinet at the top. Alright, so let's put in the sink from the front. Actually, let's put in the window. So remember we said the window is going to be 4 feet off the ground. This counter is 3 feet, so I just need to offset one more foot, 300 millimeters. So this is where the window is going to start. I just need to find the center of this room. So if I do the annotate center line and click this and this is where the center of that room would be, this line. And I'll just need to offset 3 feet, which is 900 millimeters upwards, and then I could draw this line so that I can delete the center line, and I could just offset. The window is supposed to be 3 feet wide, so I could offset 1.5 feet in each direction, which is 450 millimeters. So there and there, that's going to be my window frame, just outlining it. I could draw in my window, or I could just pull in a window from my house designer right here, like so. So let me just switch this to my openings, like so, and place this window in there. All right, so I have my counter, I have my window, I have my um, fridge, and my cabinets. Now, if you were actually doing this in real life, you would have your floor plan and then you would be pulling down projection lines from here and from here to know exactly where the windows and the cabinets are going to be. But since we don't have that and the measurements were not provided, I would just have to estimate. There's just a little space in between the window and the cabinet. Let's say that's 6 inches. Um, and put it on the counters layer. And the top of the counter, the top of the cabinet would be the same height as the window. So let me offset 6 inches, 150 millimeters, like so. All right. Now I noticed that my window is not the proper size. Look like it didn't resize. Let me measure this. Oh, it's 914 and it should be 900. So I just need to scale it. Base point, reference. The reference length is the actual size of the window, current size of the window, and then the new length is 900. So that should. I often tell people always measure anytime you're using stuff. Measure, 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 and I didn't. See? So the height, as I said, the counter is going to run across like this, and the height of the counter, well, the cabinet, sorry, is going to be 750 millimeters. So I just need to change this to the counter layer, and it disappears behind the fridge, so you're not going to see it behind the fridge like that. Okay, so let's say we have a line coming down here that represents a cabinet. 1 second. I'm going to offset this line 1 foot because this cabinet coming out here is 300 millimeters, 1 foot. So I would be seeing the top part of the cabinet that comes out. If the fridge will block out most of it, but let me just offset 300 millimeters coming out this way, and this is where the line would run. All right. So let me just switch this to the counters layer, and then I will trim away. Oh, and I will trim away there and there. So this represents the side of the cabinet, the upper cabinet, and then this line in the middle here would probably represent like the separation between the cupboards, the doors for the cupboards. All right. To make it look a little bit more official, I would double up on the lines like so. And let's say a doorknob is right there and another doorknob is right there, but you can't see them because the fridge is sticking out. All right. There you go. Okay. So I don't think I'm missing anything else. We cut through the window. If you cut through a door, it would just be to show the top of the door, and you could put two lines to represent the actual door. All right, but we're not going to put in any more details because this is not a detailed drawing. It's a section where we could see the rafters and stuff like that. But we're not going to see the exact details of the ring beam and all of these extra stuff. Unless they ask you to, you could put them in. Then that's where the knowledge of these other drawings come in. All right. So even the details of hair, we're not going to put it in like that. As a side note, we really should also put in um, hidden lines running between the footing like this. These are hidden lines. So wait, I need to delete this one, right? So these are hidden lines. The line type scale is probably off, so we need to change that to 1,000. All right. So there we have it. I think this really should be. I don't know what the thickness is. That's a little thick. Maybe we should bring it down a little bit. All right. So there you have it. Down here now we just need to put in some lines to represent some counters. How about we split this into three? I wonder if I can remember how to use the divide. I'm going to divide this line into three parts. Um, and where these are where the lines would go. Right, so I just use the divide tool. It asks me what object I want to divide. I selected the line. It asks me how many parts I want to select it, divide it into, and I type 3. So now I could just go to the counter and find the points. There are some points around here somewhere. Actually, let me just go to the P type and change it to something I could recognize. There they are. And then I would need to turn on my node snap because these are nodes. Because I need to snap to the nodes. Alright, so let's go back to the counter layer and then snap to the nodes and draw some lines down like that to represent my cupboard, my cabinets. Okay, you could also take these stuff like this and copy it and place it in to these places like so. One here, one there, one there. Same thing. All right. Actually, this looks better to me. If it goes beyond the fridge, you will need to explode it, and then, well, in this case, it does go beyond the fridge, so we need to explode it, um, and trim away the excess behind the fridge, um, and then I could switch this all back to the counter layer, counter, like so. All right, like that. So there we have. The only thing we need to do now is just dimension. They would ask you to dimension this, however. Let's go to the dimension layer. They will tell you what to dimension. If not, you will need to show, you know, all the typical dimensions. That's the footing. Let's do it the other side this way. Okay. Let's do that distance, and then I'll do, let's say, um, from there to the top of the footing, from the floor to the windowsill, the height of the window, um, and then maybe to the bottom of the eave, and so on. I could even actually probably even brought this out further. I could even do another one from here all the way up to the top of the eave and bring it out like that. I could dimension the angle of the roof, the pitch of the roof. So let me offset, um, let's say 25 millimeters, like so. Draw a line, come across like so, and then I would, let me just switch these, trim away here, and I would shorten this to, let's say, up here. This is where I would put the pitch. Alright, let me just move it a little bit. Here's where I would put the pitch of the roof in there, 20 degrees. Um, could have sworn I used 25. I guess I used 20 degrees for the pitch. No, it should be. I think it should be like 25. Actually, they didn't. I didn't use the pitch. I just used the distance, the height, to do it. So I didn't put it in manually. So that's fine. So let's just do some dimensions for like the height of the door, the width of the door. Or you could get this from the floor plan. Um, get some measurements for the height. Let me use the same distance over there. Do this. All right. Let's do um, the height of the door. 2000. All right. Um, yeah, I think we should also like label certain things. So we could point to the fascia board and say like it's 25 millimeters by 200 millimeters um, fascia board. Um, we could point to the, let's copy this. We could point to the ridge. Actually, we're not even done with the roof. We need to put in the lats. So just like when we did the eave detail and the ridge detail, you need to put in the lats. Um, let's say on top of this, I'll need to move this. Let's say on top of the rafters, we have the 1 inch 5H groove fly, which is about 16 millimeters. So let's offset 16 millimeters upwards like so. This, and then we extend these like so. So that's the 1 inch groove ply. Now these lines that are extended are not. This line is not the rafter. This is for the groove, the plywood. Um, I know the video is getting a bit long. These little fine details might take a little time. So this is the ply. All right, the groove ply. We'll have to cut it off right here. What I encourage you to do, or maybe I should just do it, it's to draw it on one side and then just mirror it on the other side instead of doing it twice. That's the benefit of AutoCAD. So I'm going to do one side. So now I'm going to put in um, the lat, which is going to be 25 millimeters, 1 inch um, away. And then the line from here, let's say from here, is going to be perpendicular. All right. So we get a 90-degree angle. So I'm going to just put the lat in here. All right. So this is one. And then I'm going to copy this and put it along here 4 inches, 100 millimeters. All right. So that distance between these should be 100 millimeters. All right. I think I clicked the wrong place. From here to here, 100 millimeters. So between these and these, there's 100. And then in the middle, remember these lats are supposed to be placed 100, 2 feet apart from this, measuring from the center. So what I'm going to do, I'm going to draw a line temporarily here so that I could select the center of that line like so. And then I'm going to um, select this line, copy it, copy them, and the base point is going to be the middle. All right. Let me do that again because I don't think I clicked the midpoint snap. I clicked the some other snap. All right, there it is. So from the middle of this lat to, let me just keep it along this. I'll go 600, 1200, 1800, 2400, 30, 3000. And maybe I've already passed the point. Actually, no. 3006 should be my next. 3600. There it is. And then 4 3600, and then 4200 should be the next one right there. All right. So um that's that those are my lats. I'm just gonna put some X's from my hatch layer to represent the end that was cut, and then I'll just copy these lines and place them. I could have actually did this first when I copied all of these down, but I didn't think that far ahead. All right, so everything I'm doing here, I'm going to mirror it over the other side, so I'm just making sure I finish this side properly. All right. So there we have the groove fly, 5H groove fly, um, the lats 1 by 4 or 25 millimeters by 100, and then we have on top of that the galvanize. All right. So the galvanize will extend across a little bit more, and then I'm just going to highlight all these things, including this line, and I'm going to do it this way to select everything inside the blue selection area. Is going to be selected. Be careful about this one. All right, and then I'm just going to mirror it, draw a straight line here, no, right, and then just extend these lines up, get rid of this. I need a ridge cap, so let me offset maybe 4 millimeters from there to there. Actually, let's do more than 4, let's do 6. So offset 6 millimeters here, here, draw a circle like from there to there, trim away everything inside from the circle. All right, and then even these lines here, and then I'll maybe cut this off around here, so I'll trim this off right there, and I could get rid of this line. So let me draw another line over here, trim it off right there, and get rid of this line. Switch this over to the other layer. So that's a ridge cap. This is my ridge cap. This is my galvanized. These are my 25 millimeter by 100 millimeter lats, center to center, 600 millimeter center to center. This is my groove ply in here. This is my rafter, and this is my ridge. So I'm going to label all of these things. I already have some dimensions, enough dimensions. I'm going to label these things and end the video right there. So let me just go to the text, leader. So I'll call this my ridge cap. Then I'll do my galvanize. call this um, galvanized sheathing. All right. I'll do. I'm on the details. This really should not be my details. I have to switch these back to my other other things. So let me point to the, because these look a bit small. So this is my um 25 millimeter by 100 millimeter lat, um 600 center to center. All right, and I could add another leader to this, pointing to the lat right there. Okay, I think I did that one wrong. The arrowhead location would be here. Now I need to add a leader to this one. Um, you don't have to put two of them. You could leave the one, that's fine. Um, if you want to point out your rafters, this would be your 50 millimeter by 150 millimeter rafters. All right. This would also be a rafter. Actually, I'm just gonna keep it simple and easy and just do the main parts. So that's the hip rafter running across there. We have the fascia board. What else? I don't think we need to really label a dimension anything else. This is the ridge board. What is the specifications of this? Let's say 50 millimeters by 150 millimeters ridge board. Yeah. So we could dimension some other things. Maybe let's move this back down into place. The question would specify exactly what they need, and the only thing we need now is just to put if you want to open up this tool palette, you hold on control and press 3, hold on control and press 3, and it will open up this tool palette. Now I could select from the metric samples, because we're using millimeters, I could select my title drawing, place it there. Notice it's really small, so I could scale it, select a base point and just scale it up to maybe that size. Whatever you do, just make sure you're consistent with your the size. So we could have scaled it using a scale factor, and I could have chosen maybe 50, you know. So let's say I scale it and I select it base point, and the scale factor is 50, and there it is. So I could make all of them that. So we'll call this section, if it's called A, whatever it's called, the scale would be 1 to 50, or whatever scale that they give you. Um, like so. And yeah, that's basically how you would do the sectional drawing. I didn't cut through anything else over here up to the roof. Good, good. All right. Okay, guys, so that's it for this video. I know it's probably a bit of a long one. So what you could probably do is do some more practice. I know we have a lot more drawings. We have um is the dance studio. We have the 2-bedroom house, which we just did. We have the 1-bedroom studio apartment type kind of thing going on there. We have the office place. Draw a section line cutting through the roof and practice creating sections for the these different drawings for these different roofs. All right. So that's where I'm going to leave this one. Until next time, happy practicing. Peace.